Okay, whether this is good news to you or not, here's the deal. When you're trying to solve for product quantity and limiting reactant, basically you're just setting up a mole problem. So you start with the value you've been given. In this case, I'm going to start with 128 grams of NH3. So I had to put grams of NH3 in the basement, and then one thing I turn it into is moles. Now 1 mole of NH3, I'll look up here, NH3, where are you? Here it is, 17 grams. Now here's what we do in all of these. This is what's different about this assignment. Now what I want to do is I want to use the balanced chemical equation to figure out how to answer the problem. So what I started off with was grams of NH3, so I have 2 moles of it. So I'm going to put this 2 down here. So I'm going to say 2 moles of this reactant is required to make how many moles of hydrogen? Well, it's required to make 3 moles of hydrogen, so I'm going to put 3 moles of H over here. Alright, now I have moles of hydrogen, so I'm going to say 1 mole of hydrogen is equal to, keep in mind, because it's H2 and not just H, the answer in this case is going to be 2 grams. And just in case you weren't sure, I was nice enough, I believe, to put it right here. Look at that. Yep. Now, multiply that through, and what you're going to get is 22, that's a 2, 22.6 grams. And you can always double check your work. You better end up with less of the product than you had of the, well, that's not necessarily true. Take that back. Alright, well, let's go on to number 2 then. Alright, now what we're trying to find is grams of silver, so we're going to make 2 moles of it. I have an unlimited amount of AgNO3, so this is not, I'm not going to run out of this, but what I have is 12 grams of Mg. So you always start off with what measurement you have. I have 12 grams of Mg, so I'm going to multiply and put grams of Mg in the basement, and I put 1 mole of Mg up above. Now let's see, magnesium right here, it's 24 grams is the formula weight of 1 mole of magnesium. Now it's where I look at my balanced chemical equation, I go, well, you know what? It takes 1 mole of magnesium to make 2 moles of silver. So I'm going to put 1 mole of magnesium down here and 2 moles of silver up here. And the question is how many grams of silver, so I'm going to put moles in the basement. I say 1 mole of silver equals, well, let's just see, what does it equal? It equals 108 grams. Didn't mean to do that. So we're going to go ahead and say 108 grams. Multiply that through, I don't believe I did this. It comes out to be 108 grams. Oh, I'm so stupid sometimes. Oh well, what can you do? Alright, let's just keep moving here. How many grams of PbI2? Alright, so I'm looking for this if I have 3.5 grams of this. So I always start off with what I know. I have 3.5 grams of Ki. So I'm going to put grams of Ki in the basement and turn to 1 mole of Ki. So I'm just going to go up to the top and see what that is. So 1 mole of Ki, it looks to me, is 166 grams. So I'm going to go ahead and say 166 grams. And now I look at my balanced chemical equation and I say it takes 2 moles of Ki to make 1 mole of PbI2. So it takes 2 moles of the reactant to make 1 mole of that product. Now I'm going to say 1 mole of PbI2 equals how many grams? I got to look up at the top and see what that is. PbI2 is probably pretty massive, I would bet. PBI2. Ooh, my goodness, look at that. It's 461 grams per mole. 461 grams. 461 grams. Going to multiply that through, I'm going to get 4.86 grams of PBI2 that are formed. By the way, we did this one a lot. That was the PBI2 is the pretty yellow stuff we made. Alright, again, we look at number 4 here. Okay, so for number 4, I'm going to start off with this many grams of iron and see how much barium I can make. So, 26.5 grams. There's nothing else to start with. I have no choice. I have to put grams in the basement. What can I turn grams into? Well, I can turn grams into moles every time. Now we're talking about Fe. So 1 mole of Fe equals, where are you, Fe equals 56 grams. It was so nice of me to do this for you guys. 56 grams. Now that's where I look at my balanced chemical equation, and I'm going to say it takes 2 moles of Fe to make 3 moles of barium. So since this right here is moles of Fe, I have to put moles of Fe down here. And for moles of Fe, it's 2. So I'm going to say 2 moles of Fe will make 3 moles of barium. And the question is how many grams of barium. So what I'll have to do is take the moles of barium here and put them down here. So 1 mole of barium equals, let's just see up here, it looks like 137 grams. So we'll go here and put 137 grams up above. And what's that going to give me when I multiply that through? How about 97.2 grams? That's a 7, by the way, my friends. Let's keep doing it. As you see, they all go pretty much the same. All right, so look at this next one. I've got to start with 17 grams because that's the only number I have to work with. What is that 17 grams of? Well, that's 17 grams of Fe2O3. So I have to put grams of Fe2O3 below and turn it into 1 mole of Fe2O3. Alright, and so now notice this one's done a little bit differently. I'm giving you how much product and asking you how much reactant. But other than that, it's not so different. The thing is, I know what I started with. It was 17 grams of Fe2O3. So let's go up here. Fe2O3 is 160 grams. So we're going to go here and say 160 grams of Fe2O3 equals 1 mole. Now I had to put moles of Fe2O3 down below, so I'm going to put 2 moles down below. 2 moles of Fe2O3 are produced by reacting 4 moles of iron. And the question is how many grams of iron, so I had to say 1 mole of Fe, and I think I remember it's 56 grams, so I'm just going to go ahead and say 56 grams is mass of 1 mole of iron. Multiply that through, so in other words, I'm just going to say 17 times 1 divided by 160 times 4 divided by 2 times 56 divided by 1. Enter. And what that's going to give me here is 11.9 grams. And let's look at our next one. Number 6. We got 3.5 grams of FeNO3. So I have to start off with that. 3.5 grams. I put grams in the basement. I turn it into 1 mole. Let's see. So now we're talking about FeNO3. FeNO3 is 242 grams. So I'm going to go here and put 242 grams. And now what I have is moles of FeNO3. How many moles of it? There's 1 moles of it. So I'm going to say 1 mole of that. And the question was, how many grams of KNO3 does it take? Well, it takes 3 moles to do it. So I put 3 moles up above. And now I say 1 mole of KNO3. You know what? I'm not even going to go. I'm not going to scroll. I'm just going to look it up. I look up the top and I see, oh, it's 101 grams for KNO3. Multiply and divide by everything I'm supposed to multiply and divide, and I get 4.38 grams. Okay, now do we come to questions about limiting reactant. The limiting reactant is the one you run out of first. So the way you do this is, you basically do what we've been doing twice. First you take 22 grams of Fe and just pick one of these 2 products. It doesn't matter which, just pick one and say, alright, I want to see how many moles of barium I can make. And then I'm going to take the other amount of reactant, 55 grams of barium nitrate, which is here, and see how many grams of barium would that make. And so whichever one makes fewer moles of a particular product, that's what you're going to run out first. So the trick here is just pick a product. I like to pick one I think is going to be easier to work with. And you have to figure out how much of any particular product you could make starting with the 2 different amounts. So here you go. Let's start off with 20. I'm going to use I think I'll use barium. So I'm going to say, all right, let's start off with 22 grams. I have 22 grams of iron, so I had to put grams of iron down below and put 1 mole. And I believe, if I remember, that's 56 grams. Okay, now I just say, okay, how many moles? It takes 2 moles of iron to make 3 moles of barium. So 2 moles of iron makes 3 moles of barium. And I don't have to go all the way to grams, I can just go to moles. So when I multiply this through, I'll get 0.589 moles of barium can be produced by 22 grams of iron. Now what I'm going to do is the exact same thing, but this time I'm going to start with 55 grams of barium nitrate. So I say, alright, I've got 55 grams of barium nitrate, so I put grams of barium nitrate down below and I put 1 mole of it up above. Now I go to the front side of this page to see what that is, and it turns out barium nitrate has a formula mass of 261 grams. And then now that I'm in moles, I say, okay, it takes 3 moles of barium nitrate to make 3 moles of barium. It's very important that in both cases, both this one and this one, I'm making barium. So in this case, I'm going to say 3 moles of barium nitrate. I need to make 3 moles of barium. And when I multiply that through, I get 0.21 moles. And therefore, this is my limiting reactant. The barium nitrate is my limiting reactant because I run out of that first. It makes fewer moles of the product. Now, it would have worked even if I had used the iron nitrate. It doesn't matter. I would have still found that barium nitrate is what I would have run out of first. Let's try this again now. Okay. So I'm going to start off with, let's see, what am I going to do? I'm going to try to see, I'm going to see how much H2 I can make. It doesn't matter. I could use Ni3, I could use, H2 is really easy. Okay, so I'm going to say, how much of this can I make? So, in fact, I'll just show you. I'm going to target this stuff here. So I'm going to say, well, I have 12 grams of NH3. So I had to put grams of NH3 to make moles of NH3. Now if I go to the front side and look up NH3, I'll see it's 17 grams equals 1 mole. That's a 17, unfortunately. It didn't look like it. I'm making it worse. Okay, now, so I have NH3. So what I have to do now is I say it takes 2 moles of NH3 to make 3 moles of H. So 2 moles of the reactant make 3 moles of the product, and when I multiply all that through, I'm going to get 1.05 moles of hydrogen be produced. Now we're going to take 245 grams of iodine. I put grams of iodine down below, and I put 1 mole of it up above. Now, iodine, if I look on the front side, is pretty massive stuff. It's 254 grams per mole, because remember, it's I2. Alright, now I had to add the step where I say, alright, it takes 3 moles of this to make 3 moles of this. Notice I have to choose the same target. So 3 moles of iodine makes 3 moles of hydrogen. And then I get 0.96. So therefore, this is my limiting reactant. So what I'll run out of first is the iodine. Now let's try number 9 and call it good. Alright, let's move this up a little bit. Okay, you know what we'll do? I'll do number 10 if you want. Alright, oh, that's a toughie. I think I told you you didn't have to do it on your homework. If I did tell you didn't have to do it on your homework, you don't have to do it on your homework. Alright, let's try this one here. Alright, so what am I going to target? I'll target the silver. I'm going to see how much silver I can make. So what I'm going to start off with is 88 grams of magnesium. And I put grams down below. Put moles up above. 1 mole of magnesium, let's look in the front, that's 24 grams. Now I have to add the step where I say it takes 1 mole of magnesium to make 2 moles of silver. 1 mole of magnesium makes 2 moles silver. And when I run that through, I'll get 7.3 moles. Now I'm going to take 155 grams of silver nitrate, AgNO3. Now, how many grams does it take to make 1 mole of AgNO3? If I look on the front side, it turns out it takes 170 grams equals 1 mole. And therefore, I'm going to look here and say, well, it takes 2 moles to make 2 moles. So 2 moles makes 2 moles. And when I multiply that through, I get 0.91, which is clearly less. So there you go. My limiting reactant is the 155 grams of AgNO3. Okay, it's my own darn fault, so I'm going to do this next one just to punish myself for even asking such a thing. Alright, so in order to do this, the first thing I got to do is I got to write a balanced chemical equation. So let's see what we've got here. We've got PbNO32, so PbNO32 plus Na3PO4 is going to react to form PbPO4 PbO4 plus what do we got here? And then we're going to have NaNO3. NaNO3. Alright, now we got to balance this bad boy. So let's see. Here's how I'm going to do that. I'm going to say, well, we've got 3 of these. So I'm going to put a 3 here. Now my lead is balanced, and that gives me 3 times 2. That's 6 nitrates. So I'm going to come over here and put a 6. But as soon as I put that 6 there, that gave me 6 sodiums, 6 NAs. And since I have a 3 here, what times 3 gives me 6? Well, 2 does. So I see what that means is it takes 3 moles of this, reacts with 2 moles of this to make 1 mole of this and 6 moles of that. That's the first thing I had to do. Now I got to figure out how many moles of each thing I have. So let's start off with I have 155 milliliters, and I don't want milliliters, so I'm going to put 1,000 milliliters down below, and I'll put 1 liter up above, and I would say 1 liter equals, now for the first one, for the lead nitrate, it's 6.5 moles. So that means I have 1.00 moles. And now for the sodium phosphate, I have how many milliliters? I have 208 milliliters. I believe that's what it was. There it is. Yep, it's 208 milliliters. So I'm going to go over here. I'm going to say 208 milliliters. And I'm going to put 1,000 milliliters down below. 1 liter up above. Remember, I said you didn't have to do this one, so don't blame me. But if you could do it, you're awesome. 1 liter equals, and what was the concentration again? Oh, there it is right here. It's 4.8 moles per liter. So that means 1 liter is 4.8 moles. And that gives me 0.9984 moles. Okay, so now what I had to do is see how many grams of sodium phosphate could I make with each of them, and whichever makes least sodium phosphate, potassium phosphate, that's how much potassium phosphate I'm going to make. So let's get going here. Now what I'm going to do is I'm going to look up the I'm going to start with my lead nitrate. So starting with my lead nitrate, I had 1 mole of it, so I'm going to say 1 mole of lead nitrate. And now I'm going to look at it and say, well, let's just see here. It took 3 moles of lead nitrate to make 1 mole. Oh, what did I just do? Darn it. It takes 3 moles of lead nitrate to make 1 mole of lead phosphate. So 3 moles of reactant made 1 mole of product. I don't want moles, I want grams. So I'm going to say 1 mole of that product equals, now I gotta look up I gotta figure out the formula mass. Oh my gosh. I gotta find the formula mass for this, so I had to say 3 times the mass of lead. So it's 3 times 207 plus 2 times 31 plus 2 times 4, that's 8 times 16. The whole darn thing is 811 grams. That's the formula weight of our lead phosphate. So I had to use 811 grams. And I multiply it through, what I can make is 270 grams of lead phosphate is what I could make if I started off with this many milliliters of lead nitrate. Now I got to see if I had 208 milliliters of this, how much I could make. Alright, well, we're almost done here. Man, do I regret asking this stupid question. Okay, well, let's see now. What I have here is, I have to start off with 0.984 moles. So 0.984 moles, actually 0.9984 moles. And I'll say, well, okay, now I'm going to see. It takes 2 moles to make 1 mole. So I have 2 moles of reactant needed to make 1 mole of product. And again, it's the same product, and 1 mole of that product has a mass of 811 grams. And I multiply that through, I get 405 grams. Now, because I run out of this one first, that is going to be how many grams I'm going to produce. I'm going to produce 270 grams. Wow, that was a bit of work.